So let's remind ourselves first what negative exponents actually are, and then we'll go over just a few problems using them and all the other exponent rules that there are. Again, not too bad since we've gone through it a few times, but just in case. Big idea. Negative exponents are what kind of numbers? Okay. So if we continue this pattern, we know that 3 squared equals 9. Divide by 3. 3 to the 1 power equals 3. 3 to the 0 is going to be 3 divided by 3, which is 1. So that was a big deal here, that to the 0 power equals 1. A lot of people will mistakenly say that equals 0. But if we follow the pattern of going up, and like 3 to the 3 equals 27, right? We just have to follow the pattern of dividing by 3 divided by 3. So if we continue this pattern, 3 to the negative 1 equals 1/3. And 3 to the negative 2 equals 1/9. Notice how these are both positive numbers. Negative exponents, positive answer. And this is kind of tricky. If you're not careful, you might think, well, a negative number in the question must mean it's a negative answer, right? But really, negative exponents are positive fractions. They're not negative numbers, positive fractions. They're just good for really small numbers. Like you're zooming in on a microscope and the width of a hair is 0.000005 or something like that. That's where this is useful. You can use, instead of saying all those zeros, you can use negative exponents. It's a lot shorter to write and it still means the same thing. So it's good for looking at things that are very small. So with that in mind, one way we looked at this and said, oh, well, 3 to the negative 1 is going to be equal to 1 over 3 to the positive 1. So if you ever have a negative exponent, all you need to do is move it from the top to the bottom, and it will become a positive. It will equal 1/3. Same thing with 3 to the negative 2. That will equal 1 over 3 to the positive 2, or 1/9, like we said right here. Okay, so we can just move it to the denominator, change the sign of the exponent, because now it's a fraction. Same thing happens other way. So if we have like a 1 over y to the negative 2, if it's a negative exponent on the bottom, it just moves to the top. So it's the same idea. The negative exponent either moves it from top to bottom or bottom to top. It just moves it. In any case, it just moves it. And so when we have, as you saw in your homework, you're going to have a lot of negative exponents in different places, so it's going to make it a little difficult. But not too many here, but right here, right up here. So we're going to have to deal with it just a little bit. I think, yeah, we're not going to. We'll do some of these down here as well. So, negative exponents. Otherwise, it's pretty straightforward. You guys remember that if you have two bases and the bases are the same number, or the same variable, all we have to do is add those exponents together. This is just a shortcut of counting. It's like saying there's 3 n's here, 2 n's here. Altogether, how many are there? There's 5. It's just counting it up. That's the same as adding the exponents together, as long as they're the same variable. And then we have the power to a power, which means you have a group of something being raised to an exponent. So we have 2 groups of 3. That was the same as multiplying the exponents. So the big deal is here is when do you know when to add and when to multiply. And we can't mix that up. And you can come up with any method you want. Some people say, well, if there's 2 bases, there's 2 numbers or 2 variables, that's when I add them together because I'm just counting up how many there are. If I only have 1 variable and 2 exponents, that's when I multiply it together, or whatever rule works for you. Remember, it's the same for variables as it is for numbers. And then we just combine it all together. It's good to break it up into parts, 2 numbers first, and then 1 variable at a time. So problems like these, I would expect you just to write down the answer right away. These are more simple. So I expect you just to look at 7 times 2 is 14. A times a to the second is a to the third. So if you're using the exponent rule, you might say, well, how do you get 3 if there's just a 2 and there's no number here? So any variable without an exponent is automatically a 1. And just think of counting. If you have 1a here and there's 2 here, you have 3 altogether. And then, of course, the b is by itself. Same thing in number 2. Numbers first, so we have -3. Then variables in alphabetical order. So we have 1, and then we have 4 more. That's 5 total. 2 x's, 2 more x's, 4 total, just like so. Now we have something, whole things being raised. So that means we have to do this. Okay, so we have x to the 4th and y to the 2nd. Is this correct? I just multiplied these, right? Everything. What's wrong? Yeah, so common mistake is, oh, I'm just going to multiply exponents, and there we go. You cannot ignore the numbers. So it's -4 to the 2nd power as well, which makes this 16, x to the 4th. So I'm very confident you guys know about the exponents and variables, so I'm just pointing out these common mistakes where it's easy to get caught up in variables and completely forget about the numbers. We got to do both. So we have to do 5 times 3, we have to do 3 times 3, we have to do 2 times 3. We also have to raise 2 to the 3rd power. We have to do that one as well. So we get 6, a to the 6th, b to the 9th, and c to the 15th. Is it 8? 2 times 2 times 2 is 8. So another common mistake, that even if you know how to raise this, sometimes I see 6's show up when it should be 8. So be very careful. 8. A to the 5th, a to the 6th, multiplying now. So yeah, a lot of easy things, right? Oh, just multiply this, just add this. But I can't tell you how many times I've seen 3 to the 3rd power equal 9 instead of 27. And 2 to the 3rd power equals 6 instead of 8. So once you think you're a superstar and you got 100% on everything, just remember that you're human and you probably made a mistake. Go back and check those little obvious things. Never mind the algebra 2 or the more complicated stuff, but look for the more easy, obvious things, because that's where I'll probably see mistakes. Check it one more time. Lastly, we'll just combine things together, so we'll have to do several properties all together. Just remember, one little negative, one little thing wrong makes it all wrong. So before you say this is so easy, I'm never showing work, think about your overall grade. Do you want to be finished first, or do you want to have a high grade? What's more important? So we got what? 4, a to the 6th, b to the 10th, c to the 2nd, times 8, a to the 3rd, b to the 4th. The negative?
Yeah.
Yes, little things, right? That's the kind of stuff I'm talking about. You get so caught up in 2 to the 3rd, you forget it's -2, miss a negative, now it's all incorrect. So being very careful. You guys got a good eye, that's good. So we got what, -32, a to the 9th, is that right? Because now I'm adding, right? So you have to switch from the multiple, when do you multiply and when do you add? So I got 2 bases, I'm just counting. I got 6 A's, 3 A's, 9 altogether. I got 22 B's, and I got 2 C's. Right? Any disagreements there? Okay. I think that's pretty much correct. Let's see here. We already talked about this big idea. Negative exponents are positive. fractions. Don't forget this. Parentheses can make a difference. This here, with no parentheses, means 3 times m to the negative 2. You have to do exponents first. That's 3 times 1 over m to the second. It moves to the bottom. So your final answer is just 3 over m to the second. With the parentheses, everything moves to the bottom. And then everything is squared. Okay. Ask yourself how many of you would have got this right. I quiz you right now on these two. Have you gotten those two answers? Right, so there's little things that you have to watch out for that do creep up. Don't assume, well, those first few problems are easy, that means everything's easy. There's other things that are a little more you gotta be careful for. So with and without parentheses, you gotta remember that the exponents, order of operations is what we're looking at here. Parentheses are first, so we can do that. Over here, exponents are first, since there are no parentheses, so we ignore the 3 altogether. Don't do anything with the 3, just the m. It's the same thing here. We'll get 1 over, or negative 1 over m to the second on this one. And over here we'll get 1 over m to the second positive. So how's your answer negative? I got positive. How'd you get negative and I got positive? Okay, it could be something like this. These small but important details. Parentheses do make a difference. That's why some of them have parentheses, some of them don't. We want to know, what does it do to the overall problem? Good. Lastly, look at some of these with the negatives. A couple multiplying, right? N to the 9th times n to the negative 9th. Okay. 2 directions we can go. We can now say that's n to the 9th times 1 over n to the 9th. Because negative exponents are just fractions, right? So that would make it n to the 9th divided by n to the 9th. What does that equal? 1. What's the other way? Just add the exponents, right? So that equals n to the 0, which equals 1. Yeah. So of course, there's multiple ways of looking at a lot of these problems. So if you guys start comparing with each other and you say, well, I got different answers, this and that, or different steps, but you got the same answer, that's okay. It just depends on what route you take. We just have to remember, don't say this equals 0 and little things. Same thing here. 2 directions. You can either say, okay, that's c to the negative 2, d to the negative 2, all over 3 to the negative 2, and then flip it all. So that's 3 squared over c squared d squared, which is 9 over c squared d squared. That's one way. Another way is flip it at the beginning. Do 3 over cd to the positive 2. Since I flipped it, you can change to positive. So whether you use distribute the negative and then flip it, each one, or if you just flip it at the beginning, and of course you get 3 squared, which is 9, c squared, which is c squared, and then d squared, you get the same answer. 2 different directions. There's actually a third one here as well. I won't show it to you, but just understand that there's multiple ways. And this makes it sometimes helpful, sometimes confusing. Some people like, just show me the one way that gives me the answer every time and don't confuse me with more. Other people like options. They want to be able to look at both methods and in their head figure out, well, it's easier and faster if I do it this way. I don't want to do it the same way every time when that could be the long way every time if there's a faster way. So 2 different ways of thinking about it. I prefer, of course, this way because it's less steps. Fewer steps means fewer mistakes. But if this makes more sense and this gets you the right answer, I want you to use that, even though it's longer. So in the end, it's more about accuracy, not speed. So here, whenever I have a negative exponent on the outside, I always just want to flip everything here. And now it's positive. So I'll get 9x to the 6th over 12x to the 12th. Exactly, 36. Okay. And of course, if possible, reduce more. So 4 goes into 36 4 times. And then we have x's. So 6 of these will cancel with 6 of those. Right? So we have x to the 6th. So 6x's on top, 12 on the bottom. So 6 of these cancel out 6 of these. Left with 6 on the bottom. Yes, no? 9 goes in 36 4 times. Yes, no?
Why is it not at the bottom?
Should it be at the bottom? So what does 9 over 36 equal?
4. No.
1/4.
Yeah, 1/4.
So yeah, this should be 1 over.
Yeah.
Again, I'm showing you, that's the kind of stuff I see. Notice how this is from the 5th grade. What does that equal? People say, oh, 9 goes into 36 4 times, and they put 4 on the top. And they're missing an Algebra 2 problem, not because of Algebra 2, but because of 5th grade. We have to be careful in details. So before we get too comfortable and say, this is so easy, not going to show work, not going to think about it, just going to talk while I'm doing homework, that's the worst what could happen. You forget little things and it turns into big things, because once you get used to doing it, what happens is that you do it every single problem. You don't catch on to it, and then you get so used to doing it, you think it's right, and then the test comes around and you find out, oh, I missed these 7 problems because of something from elementary school that I just got used to doing that was wrong. So check your answers in the back of the book, make sure you're doing things right, and to avoid all that. Okay. Chances are, if you make mistakes, they're not going to be algebra mistakes. They're going to be, I forgot a negative. 2 to the 3 to the 3rd power, you're going to put 9. You're going to put some easy mistake, but because of so many rules, it's just easy to get lost. So be careful. All right, I think that's it. Yeah, that's it. That's all I'm going to show you. Let's let you guys get to work. Just going to do 11 through 26. And again, those other problems on the back, those 3x3 review. You're going to see a lot of spiral review just for the rest of the quarter, just so by the time that final comes around, we don't really need to spend a whole week getting ready for the test. We'll just be so used to reviewing, it'll be an easy transition. Okay, and then again, if you're absent on Friday, you'll take the final tomorrow in class with a sub. Okay, and I'll see you guys on Wednesday.